now how to, so if at all a question comes, if they are mentioning by using the Phasor form, then you should know how to represent these using the Phasor form also. So let's see. So before moving on to wave equation Phasor form, I will make you understand what does a Phasor form means. So in mathematics or whatever in computation, what does Phasor means? Let's see. So Phasor representation of, we are talking about the Phasor representation of a time harmonic field. So we are talking about the Phasor representation of a time harmonic field. So what do you mean by time harmonic field? So time harmonic field means is the field that varies periodically or sinusoidally with time. So time harmonic means that varies periodically, or so periodic means a sinusoidal, cosine, whatever, like one after one definite period. So varies periodically or sinusoidally with time. So about these things you will be studying more in power electronics next time. I think in 6th semester you have. So power electronics you will study time harmonic field, THD and all you will study, or harmonic distortion and also that time. So now don't think too much about the term harmonic. So it's about varying periodically. So that value will be varying periodically. That's it. So these sinusoidal waves, so sinusoids can be easily represented as phasors. So that's why I'm talking about. So suddenly Sir started talking about time harmonic field. So why you might be thinking? Because we are going to study about the Phasor representation. So these sinusoids can be easily represented as phasors. So a phasor S, a phasor in mathematics. So a phasor Z is a complex number, which we can say Z is equal to X plus JY. So you might have studied this in your, if you have completed complex variables, you might have studied these things. So R angle theta, or you can write R e raised to J theta. So for example, we will consider a sinusoidal current and see its Phasor form. So sinusoidal current we will consider, and then that sinusoidal current will be varying with respect to time, right? So I of t will be equal to I naught cos omega t plus theta. So that is equation 1. So this is actually the instantaneous current value, right? I think you might have studied in basic electrical instantaneous value and all. So this is the instantaneous value. So this is the instantaneous form. So also this cos omega t plus theta, this cos omega t plus theta can be written as real part of, right? Real, this formula is familiar for you. Real part of e raised to j omega t plus theta. You know this formula. E raised to I theta is cos theta plus I sin theta. So cos omega t plus theta will be the real part of e raised to j omega t plus theta. Therefore, I of t can be written as I of t is equal to real part of I naught e raised to j omega t plus theta, that is equal to real part of I naught e raised to j omega t into e raised to j theta, right? So the steps are very clear. Then Here you can see I naught e raised to j omega t. The complex term I naught e raised to j omega t, as well as you have a term I naught e raised to j theta. Like you can combine together e raised to j omega t, and you have two terms. The complex term I naught e raised to j theta, which result after separating the time factor e raised to j omega t, is called the Phasor form. So this equation was together written as e raised to j omega t plus theta. The term which is obtained after removing the time factor, e raised to j omega t, the t factor, when we remove, the complex term that is obtained after that is called the Phasor form. So the complex term I naught into e raised to j theta, which results after separating the time factor e raised to j omega t, is called Phasor form. Phasor form, you represent it as Is. Okay, so Is is equal to I naught into e raised to j theta. Therefore, I of t is equal to real part of Is into e raised to j omega t, which is equation number 2. So the type of representation used in equation number 2 is known as the Phasor form of representation. So this is actually called the Phasor form of representation. So we have taken a sinusoidal signal and we have seen that how we can represent it in Phasor form. Right? So you can take any example and see how we can represent that in Phasor form. So it will be a direct substitution, direct analysis for you. So it will be very easy. So how you are representing, you have to see by using Is. So Is is how we represent Phasor forms, right? So I will just show you one more example. For example, if I of t is equal to I naught sine omega t plus theta, then I of t is equal to I naught cos omega t plus theta, because we are talking about the real part, right? So there also you should bring the cos component. So one more different type I am showing you. So I of t is equal to I naught cos omega t plus theta minus 90 is equal to real part of I naught e raised to j omega t plus theta minus 90, that is equal to real part of Is into e raised to j omega t, where Is is equal to I naught e raised to j theta minus 90 degree. So anyway you can represent. So if a vector a, x, y, z and also varying with time t is a time harmonic field. So our electromagnetic wave is actually the same expression, right? X, y, z, and so now what we considered, it is representing along z axis only. So is a time harmonic field comma the Phasor form A bar, that is As will be equal to real part of, actually it is A is equal to real part of As into e raised to j omega t, where As will be the Phasor form, right? As is the Phasor form. So that's what we have seen till now. So this is the basic understanding which you should have. Now we will connect Maxwell equations with the Phasor form. So from here it is more important. Okay. So but that was the basic. So we know that the Maxwell's equations in instantaneous form, the Maxwell's equation in instantaneous form will be del dot D is equal to rho V. Also del dot B equal to 0. The four equations, del cross E is equal to minus dou B by dou T. And also, so all these four equations should be very much familiar for you. So this four equation is what is meant by electromagnetics. Okay. So everything you study will be based on this. So these are the equation. So if you consider a charge-free medium, so if you are considering a charge-free medium, that means volume charge density rho V will be equal to 0. Then the equations will be updated to del dot D equal to 0. And also you can write del dot E also equal to 0. Why? Because D is equal to epsilon E. And then, so this fourth module is all about a lot of derivation. So you study the derivations, and then the numerical problems they ask is direct substitution. Okay. Most of them are direct substitution. So be very attentive in solving the derivations. Okay. Minus dou B by dou T. And del cross E is equal to minus mu into dou H by dou T. So we are doing the substitution in all these things. Then del cross H is equal to J plus dou D by dou T. Therefore, del cross H is equal to sigma E plus epsilon into dou E by dou T. So now we will represent E and H in Phasor form. So representing E and H in Phasor form. So how it will be? So you know how it is represented. ES and HS. So what is ES and what is HS and all? We have seen in the basics. It will be e raised to j omega theta, and we'll remove the t domain thing. HS and removing e raised to j omega terms from both sides. Therefore, what we get, del dot ES is equal to 0. That is equation number 1. Then del dot HS. So this is what we call the Maxwell's equations in Phasor form. So del cross ES is equal to minus j omega mu into HS. That is equation number 3. Then it will become, our equation number 4 will be del cross HS is equal to sigma into ES plus epsilon into j omega ES. That is equation number 4. And you know from mathematics like d by dt is equal to j omega. So these four equations are what we call the Maxwell's equations in Phasor form. So these are the Maxwell's equation in Phasor form. So just understand how the story came, like how we brought in ES. So we will have a sinusoidal function. All these things you should understand. Then we have this equation number 3, right? So we will curl on equation number 3. So these operations we have done multiple times. So taking curl on equation number 3, then del cross es. So now we are doing the same operations which we have done in the Phasor form. Earlier we didn't do that in the Phasor form. We have done in T domain itself. So now we have removed the T domain. We have obtained the Phasor form, and then the same thing we are doing in Phasor form also. So minus j omega mu del cross hs is equal to minus j omega mu sigma es plus j omega epsilon into es. So it will be del dot es minus del square es is equal to minus j omega mu sigma plus j omega epsilon into es. So minus del square es is equal to minus j omega mu into sigma plus j omega epsilon into es. So from equation 1, you know that del dot es is equal to 0. That's how we took this as 0. Then the same equation which you have obtained, del square es is equal to j omega mu into sigma plus j omega epsilon. So what you will get del square es is equal to gamma square es, where gamma is equal to the same old story, j omega mu into sigma plus j omega epsilon. And you can also write gamma is the propagation constant. So it is in per meter gamma. Then by taking now the same conclusion only. So this we can also obtain del square hs is equal to gamma square hs. So same thing which you have seen. So equation number 4 will lead you to here. Same process. Where gamma is equal to alpha plus j beta, where alpha is the attenuation constant. So one more thing you should know about attenuation constant. So gamma is equal to alpha plus j beta, where gamma is the attenuation constant, unit is Nepper per meter, and beta is the phase constant, and unit is radian per meter. So you have in your A part 3 mark question. So they can ask you what is propagation constant, what is that. So then you should write attenuation constant means how you can write when a wave propagates in the medium. So I'll give you the definition also. When a wave propagates, you should read the textbook also. So if you can read the textbook, these things are there in your textbook. When a wave propagates in the medium, it gets attenuated, right? So we have seen when it propagating in a medium, that e raised to minus term is coming, that cosine wave was getting attenuated. You saw that practically. I made it understand. I'm not simply telling you that it is getting attenuated. I show you mathematically how it is attenuated. So it gets attenuated, and the amplitude of signals get reduced, right? So you have seen how it is getting reduced mathematically, right? So this is called attenuation, and that the constant involved is attenuation constant. That is alpha. So unit is Nepper per meter. And 1 Nepper is actually considered to be 8.686 dB. And when a wave propagates, the phase change also takes place. When a wave propagates, the amplitude can get reduced, and that is getting attenuated. So that is how we talk about attenuation constant. And then phase change also takes place when a wave propagates. Phase change also takes place when a wave propagates. So that constant is described by using the letter beta, that is the phase constant. So you will study these things in detail when you study about the transmission line. So in the transmission line, how the electromagnetic waves are moving, that time you will understand more in detail about these things. Take place when a wave propagates. So unit is radian per meter. So a 3-mark question comes means these two statements you write, this gamma you write, the gamma is alpha j beta you write, then the unit also you should write. That will give you 3 marks. Then they cannot reduce your mark. So this is what all these things you should do. So what all we have studied in this module. So in this module, initially we have understood what is a wave, what is an electromagnetic wave, I have told you. Then how Maxwell's equations are used to represent the electromagnetic wave. Then we have seen the different for a medium how it is coming, then for a dielectric medium how it is coming. Then we have obtained the equations for alpha and beta. All these things we have obtained. Okay, and then now we have seen for a how to represent these equations in Phasor form. So Phasor form, how we are representing also we have seen. Okay.